All right, guys, so now that you've had a chance to listen to the Mix Level 3 file, let's cover some of the obvious things that we're hearing. Perhaps the most obvious thing is the change in loudness. You can see with our Mix Level 3 file how much louder it is just by default than some of the other files. So you can see when we start at Mix Level 1, it progressively increases in loudness. And honestly, I really didn't make that many changes to the faders in the project. This all is just kind of a byproduct of reducing the dynamic range of our audio signals. You'll also notice that the mix sounds a lot more punchy, crisp, and level. And that has to do with these transients that you can see here. Being a drum-heavy rock song, I really wanted to get the attack of the drums to pop out above other instruments in the mix. So let's take a look at the mix and start to pick apart some of the instruments and settings. And you'll see some of the choices that I made during the decision-making process. All right, so over here on our snare drum, we were able to get some more stick sound by putting on our DBX 160 VCA compressor. It's a great compressor for snare drum. And our toms, I'm actually running through an 1176 Blue Stripe, which is a great compressor for really holding an instrument down and to keep it from kind of going wild. On our main drum bus, I have a Fairchild 670, which we're just kind of touching with a little bit of compression, just to control the overall dynamics a little bit. And on our parallel drum bus, we have our TubeTech CL1B, where we're just totally killing it. Okay, so let's jump over to our kick drum here. We have our API 500 series 527 VCA compressor. You can see we have a short release, which really gives it that punchy sound. We have a higher ratio at around 6:1, which makes it sound a little more stiff and solid. And we're really bringing our gain reduction down quite a bit. All the way at the very top, I'm using the output knob to kind of drive the transient past the other instruments in the mix. Okay, so now let's take a look at our bass guitar. Now, we had a couple of goals with the bass guitar, and one of which was to really glue down some of those resonant frequencies, which we were able to accomplish a little bit with EQ. But bass guitar in general typically has a lot of energy. And one of the other things with bass guitar is we really want it to lock in with this kick drum because their rhythms do kind of complement each other. So envelope shaping was really important to get the bass drum and the kick drum to sit right with each other. And originally when I did the bass guitar, I actually tried out two different compressors. The one that's currently in the mix that you have is the good old-fashioned 1176 from Universal Audio. So a lot of times you'll see 1176 is just a really popular choice for rock bass guitar. When you push those transistors, it gives it some nice crunch. There's something about the envelopes that it can create on a bass guitar that really just help it to lock things in with a rhythm section. You can see that we really opened up the attack. If you remember, the lower the knob, the higher the attack time. Right now it's around 800 microseconds. And I just turned up our release all the way. We have a pretty high ratio, which kind of contributes to some of its leveling factors. And then we basically just use the input knob to drive the bass guitar into the gain reduction circuit. Our output knob is our makeup gain at this point. Now, the guitars I didn't really touch at all. I mean, they're really heavily distorted. And if we jump back here, you can see that their waveforms are already kind of squared off. So in the event that you ever do use compression on heavily distorted guitar, you'll probably end up taking it really easy. And at that point, it would really only be used as something corrective to fix some kind of problem. Other than that, they're really going to see enough compression later on down the line. Now, our vocals, on the other hand, are actually seeing quite a bit of compression from our Art Pro VLA. It's an optical compressor, so it does have slightly a softer knee and a slower release time, which can really lend itself to vocals. Another great choice would be the Teletronics LA2A, and another one of my favorite vocal compressors is the TubeTech CL1B. In particular with the vocal part though, we have a lot going on. Now you'll remember that one issue we had with some of the harsh S's and some of the harsher breath sounds that we were able to fix a little bit with some corrective EQ. But I did end up using a de-esser on the vocal track. You'll remember from our sidechaining video how to create a de-esser from scratch if you don't have a dedicated de-essing plugin. The important thing with de-essing though is to try to make sure that it comes before your main vocal compression. The S sounds can have a tendency of smearing if it comes after the main vocal compression, and there's not really going to be much to compress. So you can see as I play the file back here, really I only have the de-esser just touching those S's. It's not really active the entire time. It's only kicking in when those S's are happening. If you overdo it with de-essing, it can make it sound like the singer has a lisp. Now, just so that you know, there was no audio in that section. I just kind of wanted to show you visually the kind of gain reduction we had going on the de-esser. After that, we have our main vocal compression going out to our Pro VLA, which you were able to see in one of our previous chapters. And beyond that, we are feeding our vocal to some of our effects buses over here. Now, our vocal delay actually has some really cool stuff going on. So I've also turned off the audio just because it's kind of tough to talk over somebody singing. But basically what we have going on the effects bus is our delay, and it has some fairly thick settings. After the delay, I have a compressor set up, and it's a ducking compressor. So the vocal that's feeding the delay is also feeding the sidechain of our compressor. So the compressor is essentially ducking every time our active vocal part is happening and ducking the delay so that it doesn't muddy up our vocal part. And that's a super easy way to use sidechaining to get really clean and thick vocal effects. This works on most time-based effects like reverbs and delays. Now, the final thing that I kind of want to touch on here is going to be Mixbus compression, because it's really easy to overdo it and kind of have the wrong concept of what it's actually supposed to be doing. What you don't want to fall into the habit of is using Mixbus compression as a way of protecting your outputs or preventing clips. When you're mixing, you should be leaving enough headroom to not even get close to that 0 mark. Save that for later. Mixbus compression is a way of adding what I refer to as pressure in a mix. So with Mixbus compression, I'm using this SSL G-Bus compressor, which is really one of the holy grails of Mixbus compressors. It has a few features that are really tailored for Mixbus compression. One of those features is namely being the post-compressor auto fade. And you'll see several versions of this plugin out there. I know that Waves makes one, and Solid State Logic also makes a Duende native version of the bus compressor. But we're using the Universal Audio UAD version right now. Now, the main thing with Mixbus compression to get pressure is not to just insert this compressor on a mix bus and call it a day. Really, the motion and the pressure that we get from Mixbus compression is going to come from how hard we drive our signal into the compressor. So in this DAW, we're lucky enough to have actually some post-fader inserts, which means this compressor is actually occurring after this fader. So the lower we bring the fader down, the less signal we're sending into the compressor, and the higher we bring it up, the more we're sending into the compressor. So when we start doing our Mixbus automation, we can start to push our fader up during some of the louder parts like the chorus and the very ending, and drive this compressor just a little bit harder to get a little bit of extra pressure. Now, if you don't have post-fader inserts on your Mixbus, one way that you can accomplish this is by inserting a plugin that has some kind of volume control before it. I'm just going to insert just a regular plain old EQ plugin. You'll see that this just gives us a volume control. So when it comes time to mix down, instead of automating our Mixbus fader, we can start to automate this output control and drive our mix more into this compressor. If you're doing it this way, just leave your master fader as is, don't touch it. Now, the one benefit of automating your Mixbus by using a different plugin as your master fader is that you can actually use the main fader at this point for a post-compression fade out, like the auto fade feature on our SSL bus compressor, meaning that if you do have a fade out at the end, that fade out will have no effect on the gain reduction circuit of the compressor. So I know that this is a lot of information to take in, but next time you sit down to mix, I just really highly encourage you to start thinking about the audio that we send into compressors. Don't get stuck into following those recipes. Really use your ear and learn how compressors have an effect on the dynamic range of an audio signal. In the next video, we're going to see how we can use compression in a mastering environment to accomplish some very specific tasks. So take a short break and we'll see you in the next video.